Graphs are powerful tools used by scientists to convey big ideas in a digestible manner. In this video, we'll look at a few different graphs to see what we can determine from them. Take a look at this graph that plots the number of bubbles an underwater plant produced at different distances from a light source. Graphs make it really easy to look at relationships between variables. In this graph, the two variables are the number of bubbles and the distance from the light source. One of the variables is the independent variable and is what is being changed by the researchers in the experiment. What is the independent variable in this graph? The independent variable is what we are changing in the experiment. Some people refer to it as the manipulated variable. We are changing the distance that the plant is from the light source, so this is the independent variable. You'll notice that this is represented on the x or horizontal axis. The independent variable is always found here. The other variable, the dependent variable, is the variable that is affected by the changing independent variable. What is the dependent variable in this case? We already said that the independent variable is the distance from the light source. Our graph tells us that the distance from the light source affects the number of gas bubbles that the plant produces, so this is our dependent variable. Some people call the dependent variable the responding variable because it responds to changes in the manipulated variable. It is on the y-axis or the vertical axis of the graph, and this is where the dependent variable always is. This graph, and all graphs, let us easily visualize the relationship between the independent and dependent variables. In this graph, you can see that the closer the plant is to the light source, the more bubbles it will produce. As the plant gets farther away from the light source, it will produce fewer bubbles. Now let's look at this graph that plots the number of COVID-19 cases from January to May in 2020. In this case, the two variables are the date and the total number of COVID-19 cases. Which of the two variables is the independent variable? The independent variable is what is being changed during the experiment. In this case, what is changing is the amount of time that is passing. Time is not something that the researchers are necessarily changing in this case. Time is just changing by itself. However, the number of COVID-19 cases depends on time passing, which is why time is the independent variable. Dependent variables are the ones that are affected by the changing independent variable. What is the dependent variable in this case? The dependent variable is what is affected as a result of the independent variable changing. The amount of time that has elapsed is changing, and the number of cases changes as a result of this. In other words, as more time passes, the number of cases increases. The number of cases, then, is the dependent variable. It's on the y-axis or the vertical axis of the graph, and this is where the dependent variable always is. Graphs allow us to visualize trends that might otherwise be difficult to see by just looking at the numbers. On this graph, we see that the number of COVID-19 cases rose steadily from January to mid-March. Starting in mid-March, we can see that the number of cases starts increasing at a much faster rate. If we look at any one point on the graph, we can see how many COVID-19 cases occurred up until that date. How many cases occurred up until April 1st? We want to look at the number of cases that occurred up until April 1st, so we'll draw a point on the line that lines up with April 1st. This point that we drew also lines up with the value on the y-axis. We can draw a line from the point to the y-axis to see that about 1 million cases occurred before April 1st. In this video, we talked about all of the information that we can gather from a graph. Graphs tell us about the experiment and the relationships between the independent and dependent variables of that experiment.